Micro Mouse is a competition over at it's some universities participate in that competition, where students make robots about the size of your palm, and the robots have to self-navigate in a maze and try to go from one point to a destination as quickly as possible.
Should do it for it. I heard you did it at Davis.
Yeah, I did it over at Davis, but that's about 4 years ago. When UC Davis, or when the entire UC ran out of money, they decided to let go of all the adjunct faculty, all the lecturers and whatnot, to save money.
So you got fired, basically.
Well, I was basically let go. There was no there's no tenure for lecturers, so there's no guarantee of employment as far as I was concerned. So they so the teaching assignment was on a year by year basis. So they just have to say, oh, sorry, we are not going to offer that class this year, so you won't be needed anymore. Yep. But it was a fun class, and many of my students get their first jobs because of that final year project, because it helps students understand the entire process of designing and making something, and also how to work in a team environment, do their own project management, their own time management. So even though if the project fails, okay, they can still go to an interviewer, and in an interview they can still talk about the whole process of how to design something, what they learned in the process and stuff like that. And as it turns out, that was actually useful in interviews. The interviewers typically do not care how much people know about device physics, all the math equations and whatnot. They want to know whether these people are workplace ready or not. Yep. It was a final year project class for mostly electrical engineers. However, I do have some computer science students taking that class, but out of their own interest, because that class does not count as one of the required courses in computer science. So they will have to basically quote-unquote pay out of their own pocket to take that class. It's a 5-unit class. It's really kind of, is it 5? Yeah, it's a 5-unit class over 3 quarters at UC Davis. So the first quarter is 2 units, the second quarter is 2 units, and then the third one is 1 unit. It was a really fun class. I mean, students actually build the entire robot from the ground up. They don't just buy a kit where you just put something together. There's instruction to do it. No, they have to design the whole thing from the ground up, and then they go to Tab Plastics to purchase like acrylic plastic. They have to cut it. They have to glue all the pieces in place. They have to specify and purchase their own motors, design their own circuit board, write the programs to run on those circuit boards, solder the whole thing, test it and make it work. So it's a complete design process. Many of my students, also design their own circuit board. I mean, they knew nothing about circuit design, before that class, and then when it's all done, they can actually show, a potential employer and say, I can go through this entire process. Tell me what you want to do, and I can, go through the entire process to make it happen. And that's valuable. I taught that class long enough that some of my earlier students became managers or even owners of companies, and they quote-unquote accidentally hired some of my later students, only to find out during an interview that, oh, you took Micro Mouse from Tech too? Yeah. That was funny. I think that was one of my highlights, is having my older students, as managers or even owner of companies, to hire some of my newer students. So they're hiring basically, alumni from that particular program. So that's Micro Mouse in a nutshell. The technical challenge is not nearly quite as important as the project management, and all the more practical aspects of being employed as an engineer. So I think that's it's a really good class from my perspective. It's very time consuming on my part, because at the beginning I act as a lecturer or a instructor, and then halfway through I shift my role to become a consultant. In other words, students will be doing their own thing. I give them all the basic knowledge that they need in order to design something, but I'll let them do whatever they want to do. So I become a consultant, and then later on after that, I become a technician because I would help them, solder the components and also debug the circuit boards and stuff like that. So I basically turn into a technician, at a later stage of that class. So it's really fun. A lot of times also kind of stressful sometimes because the team dynamics is one of the big things. I mean, that really determines the success or their lack of a team more than anything else. My best teams tend to be, not always, but they tend to be students who get usually Bs, B plus, B minus, at UC, and not the A teams. I have plenty of A teams where, students have, good grades. But if you have more than one student with exceptionally good grade in a single team, sometimes it gets difficult because they all have bigger egos. Because they look at their own GPA and say, well, I have a GPA of 3.9 something. I only got a C in a history class, right? And then the next guy would do the same thing and say, well, I know just as much as you do, so you don't get to tell me how to design this thing. I think my idea is better than yours. And then you have problems from that point on. But the B teams, on the other hand, are typically more modest students, so they won't fight within themselves. They would come to me and ask, okay, what do you think, Tack? We come up with these alternative designs. How do we evaluate these designs? And they don't really take it personally when I say, okay, this design may be better. This is a good plan B, and so on. So it's interesting. Team dynamics is very, very interesting in that class. But I think in the workplace, it's the same way too. It's the same way too. The only thing I did not do to make that class even more realistic was to grade by curve. In other words, I could have used the competition to say whoever wins first place, the entire team gets an A. But if you are second place, you get like a B. Or if you're second and third, you get a B plus and a B, and then the rest we get a B minus and so on. I did not make it that way. I just made it so that if they can get the robot working and solve the problem on picnic day at Davis, the entire team would get an A. So if you are with a team that is really good and the next team is trying to get there but not quite there, a lot of times, the more advanced teams would help out the other teams because their A does not depend on their relative position in the competition. As long as they can solve the maze, they get an A. So a lot of times I have teams helping out each other, which I think is also really nice too. Instead of being more cutthroat, like if I help you, you might win the competition, and I end up getting a lower grade. So I did not really encourage that type of cutthroat thinking in my class, and that made it less realistic. Because in some companies they actually encourage employees to be more cutthroat, so that they all become more competitive and they work harder that way too. But I just don't think that really is the right way to motivate people. All right. Any questions?
Do you have any of those robots?
I do not. I do not personally own the robots. I let the students keep their robots so that when they go for interviews, they can show their potential employers, what they have done, and they show the documentation and stuff like that. But if you go to YouTube and just look for Micromouse, MICROMOUSE, just like small mouse, and UC Davis, you'll find a lot of my student video. Especially with the later classes. I started teaching that class before YouTube became commonplace, so there were a lot of older designs that you cannot find online. All right, so there is that. So let's go to this homework assignment and do this assignment first, and then we'll continue to talk about pre and post conditions. Right. This is the pseudocode already indented correctly as per what we did on Tuesday. So what we'll do today is simply to trace it and figure out what this algorithm is going to do. Now it would be helpful if people have read the notes as well before doing the homework assignment, because the notes also kind of talk about how do we deal with tricky places in
Professor,
an algorithm.
Is this due today?
Sorry?
Is this due today?
Yep, it's due today.
Not a week?
Not a week.
Okay. I thought everything is a week. Oh,
No. This one was kind of an exception to that case because originally the entire thing was due on Tuesday, including the trace. So I said I split it up into two parts, where the indentation was due on Tuesday, and then the trace is due today. So basically, today is an extension to what was originally due on Tuesday.
I didn't hear that, okay.
Okay.
I just did both Tuesday.
You did both to begin with? Okay. All right. So let's take a look at comments. And then we have line number. And this time we have two variables. We have variable x and we have variable z. So we'll take a look at what this algorithm is going to do. All right. So we start with the precondition. With the precondition, since I did not say anything about assumptions of the variable x and z, and also if you look at lines 1 and 2, the values of these two variables get completely overwritten just by the first two lines, which means even if you make any assumptions, it's not going to be very helpful because we're going to overwrite those values right away. So that means we're going to assume that we don't know anything about x or z, and then we'll start execution on line 1. Line 1 initializes x to 0. Line 2 initializes z to 0. And then on line 3, we have to evaluate the condition. Z is less than 5 is true. And then we move on to line 4. The reason why we move on to line 4 from line 3 is because the condition of a while loop or pre-checking loop is true, so we enter the body of the loop to perform the operation. Are we still doing okay so far? Why we are moving on to line 4? Okay. Now once we move on to line 4 is the beginning of a conditional statement. So we have to evaluate the condition of the conditional statement. X is less than 2 is true because x has a value of 0 at this point. So we move on to line 5 at this point because that's the then branch of this conditional statement. And I think most people can get to this point. Getting into the nested structure is the easy part. Getting out of it is actually the harder part. Okay, so getting in is okay. Most people can probably get this part. Okay, so once we get into the conditional statement, the outer conditional statement, we execute line 5. Line 5 doesn't have a choice. Once we get into the then branch of the conditional statement, we have to execute line 5, and so z gets incremented to 1. And then we get to line 6. Line 6 checks whether x is greater than 1, and the answer is false. That is not true. So now where do we go?
12.
We go all the way to 12. That is correct. Now I have to explain why we're going to 12 at this point, because when we are on line 6, okay, I can see a lot of reliefs. Okay, when we're on line 6, we have to evaluate that condition. Now that condition is false this time because x has a value of 0. 0 is greater than 1 is false. So we don't have, we're not going to execute the then branch of this conditional statement. And yet at the same time, it doesn't have an else branch either. So that means we're done. There's nothing to do for this conditional statement. So we skip all the way to after, quote unquote, to after the conditional statement from line 6 to line 8. But there's nothing after that, which means at this point we are done with the entire then branch of the conditional statement starting on line 4. Okay. Now when you're done with one entire branch of a conditional statement, you get out of the entire conditional statement. The end of the conditional statement starting on line 4 is line 11. That's the end of that entire conditional statement. But we don't trace line 11, we trace the line right after that, so that would make it line 12, and that's why we are continuing on line 12 at this point. The next line is line 12. Line 12 is adding 1 to x. X goes from 0 to 1, and then after that, we are now at the end of the entire loop. Since this is a pre-checking loop, and when we're at the end of the entire loop, we have to go back to the beginning to reevaluate the condition. So now we have to go back to line 3 to reevaluate the condition to see whether we have another iteration to perform. Are we still doing okay at this point? Okay, having a picture would definitely help. For if this is the first time we deal with something like this, having a picture would certainly help.
Yeah, I got lost in the picture.
You got lost? Okay.
I'm not a visual person, and
Mhm.
so a picture isn't going to help in this case.
Okay.
Knowing how it functionally works versus
Yeah.
what it looks like would have been
Mhm.
helpful to do the homework.
Right.
Like it's just like as a suggestion, like I didn't knowing how it works to me. The picture, I mean, that's all fine and dandy, but I'm not a visual person. I'm not going to learn that way.
Okay.
So maybe having an alternative to like this is how it functionally works, like because the examples that you have were different. Like it didn't have another if then statement nested in there to be able.
But
to
it doesn't. But it really does not matter whether it is an if-then statement or not, because the entire if-then statement is a single statement. So you have to treat the entire if-then statement. Are you referring to line 6 to line 8?
Yeah, but it matters to me. Like being able to reference and see how it functionally works, because it doesn't look or feel the same as the other. It's different to me. It's I that's just a suggestion. I mean, I just wanted to point that out. That's all. Because
Okay.
drawing a picture doesn't help me. I tried. It doesn't help me at all.
Okay. Yep. Go ahead.
Just on the notes online, you had more extensive commenting, so that's what I used as kind of a reference. Like, for example, number 5, line 5, I put, that statement's true, and then I put the comma, I'm sorry, I mean line 7.
On line 7?
Or line 5, I put.
Line 6, you mean?
That deals with line 5.
Yeah, we don't get to line 7. Line 7 is unreachable.
I'm sorry, no, okay, dealing with line number 5, which is on line 7,
You can add additional comments if you want. I mean, that's fine with me.
You don't require it?
Sorry?
You don't require it?
No, I do not require any additional comments. So when you read the notes, that's it's okay if you want to add additional comments, like explain why we're getting out of here or why we're jumping all the way to a particular place, but it's not required. What I'm describing here is what I'm looking for, but if you have extra stuff, as long as it does not conflict with the actual answer, it's going to be okay. Okay, but are there any questions at this point about why we went all the way from line 6 all the way to line 12?
Yep.
Question? Okay. Yep, go ahead.
I'm still not seeing how you went from 6 to 12. There's no, I'm not seeing any path.
You're not seeing any path, okay?
All I'm seeing is 2 different lines. It looks like you just went from 6 to 12.
Okay, go ahead.
I think if you were to just take out, I guess, line 3 and show how, but
All right.
that's it. I can't explain it, but it's kind of like you're in a section. You're looking at a section. That's why you skip all the way through. It's because there's like 3 different things that you have to do.
Okay, line 6 to line 8 is one single conditional statement. And because the condition of that conditional statement is false, there's nothing to do from line 6 to line 8. But line 8, from line 5 to line 8, is the entire then block of the conditional starting on line 4. So when you're done with that one branch of the outer conditional statement, then you have nothing else to do. And the only thing that's after the outer conditional statement is line 12, and that's why we have to proceed to line 12. Yep.
Like the way I seen it, like it took me like 2 hours to figure it out. But if you go to line 10, like it's just gonna repeat itself. You're never gonna get out of it. Like I know it's wrong, but that's the way I seen it.
Okay.
I see it a little.
Okay, let me answer her question first and then back to you. Sorry. Go ahead.
Okay, my initial understanding was that if line 6 was false, then line 9 would get executed and then you would trace line 10. But how, if that...
But that
since
else...
that's for
Okay,
both,
but that...
we did skip to line 12.
But the problem
Wait,
is that... The problem is the else on line 9 is not corresponding to the if of line 6. It is not a part of that. line 6 is ended by line 8. That end if is ending line 6 already. So that else on line 8 is really corresponding to the if on line 4. So that's why we don't go for that else. We don't go for line 10 when the condition of line 6 is false.
So when is
Four is
line
false.
9 going to be executed? Like
When
now?
4 is false, then you go
When
to
4 is
else.
false.
Right.
Okay.
When the condition of line 4 is false, then you go to line 10, because line 10 is the else branch corresponding to the condition of line 4.
It's the indents that indicate it. They like
The indentation should be helpful, should be indicative. Yep. Go ahead.
I'm okay.
You okay? All right. Because I just want to make sure that I kind of answer it in the order. Yep. Go ahead.
What if I put 11 and then 12? Is that wrong too?
If you put in line 11 and then line 12, that's not kind of how I trace it. For a conditional statement, it is not confusing, but for a loop, tracing the end while is going to be confusing. So, so I'm going to say it, and since it's being recorded, you can hold me accountable for that. So for this homework assignment, if you trace line 11 and then straight to line 12, I'm going to count it in as okay. Okay, but in the future, we do not trace end if or end while, because those lines do not actually do anything. And therefore, we don't want to trace those lines. For this one, I'm going to count it in, just as long as you go immediately to line 12 from line 11. So that's a condition, right? Okay, so if you go to line 11 and then you go somewhere else, it doesn't count. It only counts when you go from line 11 straight to line 12. And you have to go to line 11 either from line 8, from line 6 or from line 10. Okay. So the flow still has to be correct.
I went from line 6 to line 10.
You go from line 6 to line 10, that would not be correct. Because line 10, once again, is the else of another conditional statement. And this is why, I personally think that, drawing a picture may be helpful, even though, some people may not find it useful. The other thing you can also do is to use a flowchart, but it's also just another visual way of looking at things. And I don't like flowcharts because it is not structural. You cannot have in general, you don't have a flowchart inside another flowchart.
But you can just highlight, like, how you have the indentation, like just highlight the ones that correspond to that block. Okay. Let's say, like, I highlight while all the way to the end if.
Okay.
That was like a whole block, like if to
Yeah.
the end if, and then I was just like working on that. And then
Okay. Let me try something else. Let me see if it helps if I translate this into MIT Scratch, okay? Because MIT Scratch actually has the entire block. Things are actually in blocks. Let me see if this helps. Let me see if this helps. Okay, if it does, good. If it does not, then we have to find something else. Okay, so we'll go to scratch.mit. I'm using it as a tool to represent the logic. I'm not using it as an assignment. So don't worry if you do not know how to use Scratch. I'm just using it to visually show you how to interpret the pseudocode itself. All right, so let's go ahead and create a new project. We have two variables. So we go to data, and we say make a variable. The first one is x, and then we make another variable. The second one is z. Okay, and then we go to scripts, and now we can actually start to write the script. For the control block, we'll start. Well, actually, I need an event to start the whole thing. Okay, so here's the green flag to start the entire algorithm. And now I need to refer to both the algorithm and the picture at the same time, which is going to be a little bit difficult because my screen is kind of limited in size. So I'll just have to kind of flip-flop between the two screens. We initialize x and z to 0. So here we have the initialization. So we go back to data, and then we set z, in this case, set x to 0 first, and then we set z to 0. Okay, so those two little blocks are assignment statements. I know it's pretty hard for you guys to see because the icon is hiding. But when you watch this from the video, you can actually freeze the frame and my YouTube videos tend to be pretty good in terms of resolution, so you should be able to read it well, when you watch it from the video. But that's not really the important part. The important part is really, how is the whole thing structured. So I'm gonna, that will be the most important part of this demonstration.
Yeah, but once you go to 1280, it's all fuzzy.
You should not be fuzzy at all. When you go to when you use the HD, 720p.
Oh, okay.
Yeah, you can change the resolution of YouTube. You have to bump it up to 720p, and then it will be pretty much the same resolution as what you see on the projector.
Yeah, it is in 720. But I guess my settings on my computer is a little too high.
It also depends on your speed of connection. If you have a slower connection, it might force itself back to a lower resolution. Okay, the next thing we do is the entire loop here. So what we do in Scratch is to go to control, because a loop is a control structure, and then we try to locate a while loop. It doesn't really have a while loop, unfortunately. It has a repeat loop, but since the until condition is at the beginning, it is still a pre-checking loop, okay? In terms of the structure, this is still the correct structure. It's just that we have to flip the condition, because this is specifying, okay, when are we getting out of the loop instead of when are we staying in the loop. In my original code, to stay in the loop, I want z to be less than 5, so that means in this case I want to get out of the loop when z is no longer less than 5. So I have to go to operators, pick a negation first, and then pick a less than, and then we can say when z is not less than 5, so we pick z and put it here, and then we just type the value of 5 over here. Because when you talk about repeat until, you're specifying the exit condition. When are we getting out of the loop? When you use the word while, it's the same as long as, which means we are specifying the condition to stay in the loop. Okay, but the most important part is the structure. Okay, this is a loop. Now we put stuff inside the loop. The first thing we put inside the loop is a conditional statement. It is not just a conditional statement. It has a then portion and an else portion. So we have to be careful in Scratch to make sure that I pick the if-else construct here. So that's the block that I put in here. And then the last instruction is to increment x by 1. And over here we have a few ways to do it. You can say change x by 1, which is also the same thing as incrementing. So I'm going to just use that as a shorthand. Now this is also important. Even though you may not be able to see the individual words, you can still see the block. You can see the conditional statement block is at the same level as the change block here. Is that okay so far? Okay. So that means after you're done with the entire conditional statement, it doesn't matter what's in it. It doesn't even matter whether the condition is true or false for the conditional statement. You still have to perform change x by 1. I have to change that to change x by 1 instead of change z by 1, because over here it is changing x by 1 or incrementing x by 1. So I'm going to change this to refer to variable x here. Are there any questions about the construct or the structure of this code at this point? You don't have to focus on the little details, just focus on how the blocks relate to each other. Is that okay? All right. So now we go in here. In fact, what I'll do is I'll finish the structure first, and then we'll go back and specify the details. Inside the outer conditional statement, we have an assignment statement, which is by itself, and then we have another conditional statement next to the assignment statement. So the way to do this is we specify the assignment statement, and then we have another conditional statement right after the assignment statement. So let me go back and double check. Z is incremented by 1, which is done by this one, and then we have the conditional statement down here, which is represented by, oops, starting to run the program, stop. There we go. So is that okay? Does everybody understand the structure of the code? Which block is containing which other block? Is that okay? All right. And now we can go back and specify the rest of the details. The condition of the outer conditional statement is x is less than 2. So we go to operators, because comparison is an operator. And we specify variable x over here, and just specify a constant of 2 over here. And then the condition of the inner conditional statement is x is greater than 1. So we do about the same thing. Go to operators, choose the greater than operator, put it here, go back to data, drag the variable x over here, change this constant to 1, and then we go back here. We are incrementing z by 1 if x is greater than 1. So we say change z by 1 and put it also over here. Only one thing left to do, which is the else branch. The else branch is corresponding to the condition of line 4. It wants to increment z by 2, which in Scratch is basically saying change z by 2. Over here. Oh, no, don't write it. Change z by 2. There we go. So that's the entire program, expressed in Scratch. And just to be nice, I'm going to end the program. So we say, stop all, and just put it here, just so that it looks correct. Are there any questions about the structure of the code? Because the most important part is where does a block relate to the other blocks? That really is the main purpose of this homework assignment, is to show you guys how we can nest one construct within another construct. Is that okay? Not.
And then have two completely separate constructs in the same loop as well? Because line 12, that x plus 1 is irrelevant in comparison to the other if-thens.
Line 12 is right here. Line 12 is down here.
Yes.
And it is after the entire conditional statement, the big conditional statement.
So it's like just two separate operators. So we're doing the if-then as one function.
The if then else is 1, and then you have the increment of x after that, right? Are there any questions about this one? Would that is that helpful? I mean, would that kind of help you functionally understand the code?
Yeah, a little bit. I'm just curious how you're going to grade this. So.
Well, I'm gonna have key indicators. In other words, at every point where the continuation is not because it is a sequence, I will look for those transitions, because it is those transitions that are important for this homework assignment. All right. Are there any questions about this demonstration? Using Scratch as a tool to demonstrate the structuring part of the code.
Can you run that?
Oh, obviously, yes. Yep, you can run Scratch. In fact, when we run it, okay, I've actually ran it already. That's why x and z had some values. So when you run it again, well, it ran a little bit too fast. There's a way to run it step by step, if I remember correctly. Let's see. Let's see if I can. I know there's a way to run it, gradually, slowly. I just cannot remember how to do it. Yeah, this is just going to run it at full speed, so we can't really see what happened in between. But the last version of Scratch, had a way to do it, just slowly. Is it in motion? Yeah, that's going to move the mouse. That's going to move the cat itself. You can always insert looks here and just use these constructs to stop it for like a second or two. But I thought there was another way to do it slowly, so that you can see how the blocks update themselves. Apparently that's not the case. Or for whatever reason, oh, okay, there's a way to zoom it in. That's helpful. But you can definitely just run this code and try to find out how to trace it step by step. Small stage, turbo mode. Okay, now it's in turbo mode. I'm going to turn it off. Tips. No, we don't want tips. I don't exactly know how to make it go very slow. You can always insert some additional weights and sleep functions to make it go slower. And I think you can go to control and put just wait 1 second over here. Then for each iteration, it will wait 1 second before it goes for the next iteration. So if I do it this way, you can see the values get updated like kind of slowly. So you can put in additional weights, so that it will slow down the execution of the code. All right, is that okay? I mean, I'm gonna grade this, based on how you proceed from each point. If I go to the trace here, okay, if I go back to the trace, I can tell you, what I would do with this one, because from line 6, I would try to see whether you go to line 7 or you go to line 12, okay, because from line 6 we should be going to line 12 directly. If you go to any other line, then you won't get the point of continuing execution on line 12. So it's those particular points that will be important to me as far as grading is concerned. All right. Are there any questions?
Did we finish the sentence? Yeah, can we finish the trace?
Oh, let's go ahead and finish the entire thing. It won't take long. I mean, it looks like it will take a much longer time, but it's actually not going to be that long. Okay, so now that we're back to line 3, reevaluate the condition. Z is less than 5 is still true, so we go into the loop here. We go back to line 4. X is less than 2 is also true because X has a value of 1 at this point. So when the condition of a conditional statement is true, we go for the then branch, which is now starting on line 5. Line 5 is adding 1 to Z. Z gets incremented to 2. And then we go to line 6. Line 6 is still asking the same question. Is X greater than 1? That answer is still false because X has a value of 1. 1 is greater than 1 is false. Okay? And because the answer is false, we skip over line 7. We go all the way to the end of the conditional statement. But the conditional statement on line 6 all the way to line 8 is the last statement of the then portion of the outer conditional statement starting on line 4. So this means we are now done with the outer conditional statement. We have executed one branch of the outer conditional statement completely, and it's time to get out of the outer conditional statement and continue after that. So that means we are now continuing on to line 12. And line 12 is just adding 1 to X again. X is now 2. We go back to line 3. Z is less than 2. Z is less than 5 is still true because Z has a value of 2 at this point. Now right here, I'm going to use this trick here so that I can show the top part of the columns and be able to scroll the bottom part here. Okay. So after line 3, we get into the loop. We go back to line 4. But this time when we are on line 4, X is less than 2 is false because X has a value of 2 at this point. 2 is less than 2 is false.
So you're going to go to line 10?
So this time we go to line 10 because line 10 is the else part of that conditional statement. Okay. So line 10 is going to add 2 to Z instead of 1. So Z is now incremented to 4. And then we get out of the outer conditional statement, continue execution on line 12. X itself is incremented by 1. Oops. So it goes from 2 to 3. And then we go back to the beginning of the loop, which is line 3. Z is less than 5 is still true, but only for the last time now. Okay. So we have to go to line 4. Line 4 is testing whether X is less than 2. That is false. We go to line 10. Z gets incremented by 2, so it goes from 4 to 6. And then we continue execution on line 12. X is incremented by 1. It goes from 3 to 4. And then we go back to line 3 one last time. We cannot get out yet, okay? Because for a human, we can see that, oh, Z has a value of 6, and I can look ahead and say, hey, the loop should be done now because Z is no longer less than 5. But to a computer, it cannot scan the program like we do, okay? It can only see one line at a time. So that's why we still have to go back to line 3 and then reevaluate the condition of line 3 and then say, oh, it is false now, and this is the time that you proceed to post. So that is the entire answer to this particular assignment. Yep.
And then doesn't matter what X is, because you're not taking any more steps, so after, on 23, line 23, since it's false, you don't look at anything else, right? You're done. Like, you can't, like, program stops.
The program, there's nothing after line 13 in this case, so that's why I use the word post to indicate this is the conclusion. The entire program is done at this point. Yep. So I'll be looking for that word post too, because it is an indicator that, okay, we're all done. Instead of, well, I forgot to finish the homework assignment. I can only work up to here. I went to cook dinner and then forgot about the whole thing. So the post actually has significance as well. All right. Are there any questions? No questions?
I messed that one up.
Well, that's what the homework assignments are supposed to do, is to let you know how much you know, and it lets me know also how much you know, and then we can. I mean, like today we spend a little bit more time and choose a different way to explain the concepts. So that's what it's supposed to accomplish. Yep.
I'm sorry, I didn't turn in this assignment, so I was wondering, when you turn it in late, do you get any credit?
No. The syllabus said no late, no late submission. Yeah. Yep.
What if I did the trace immediately and I forgot to turn the assignment in this time, but I have it in the original file?
If you don't turn it in, then I cannot see it, right?
No, I haven't. Last week's submission, I submitted it, then it had all my trace in there.
That one has your trace already. That would be fine. You just have to.
I made a note.
Yeah. Okay. Yeah. Just in that case, since you turn it in already, if I accidentally look at your submission for the second part of it and I say, oh, okay, you didn't turn in anything. If I give you a 0, just remind me that the answer is in the previous one. You already turned it in.
Okay, I like the comment.
Okay. All right. Yep.
It's about actually the pre-post assignment.
Okay.
I just wanted to ask if if post 2 is the same thing as pre-3.
Okay, the pre and post homework assignment, well, I'm glad you brought it up, because I was just about to talk about that. I think I spent a little bit too much time on this one, so we'll see how far we can go with the pre and post conditions such stuff, because if I cannot get through enough material, I cannot assign that homework assignment. Okay. All right, so I'm just gonna call this one done for now and move on to your next homework assignment.
When is it due?
It's due in a week from today. However, I have to take a look and see how much I can cover today to give you the material that you need to do this homework assignment.
And so this is still topic 3?
Yeah, this is in topic 3, and the homework assignment is this one here, pre-post assignment 1. All right, so we'll take a look. Oh, there's one submission already.
That's me, sorry.
That's okay. You can always use Moodle to kind of help you like keep track of your homework assignment. In other words, if you want to continue to work on your homework assignment, you can download the file on another computer, keep working on it, and then re-upload it back onto Moodle. That works too. So this is your new homework assignment. Yep.
Attendance.
Attendance. All right. Thank you. All right. So this is your new homework assignment. Let me just kind of bump up the font size first so that you can see what it is about. There we go. And you can see that I decided not to use actual values for x and for j and k, so they're just okay, j is a particular value, k is a particular value, but I'm not telling you what they are. So the whole purpose is to make sure that people do not trace this particular pseudocode, and instead they have to analyze the pre and post conditions of this particular one. Now we really have not gone through enough steps to talk about this, okay? So what I'll do today is I will use the remaining portion of this class to try to cover as much as I can to see if I can cover enough material so they can get started with this homework assignment. All right, so what we'll do, we talked about the general stuff already like this. So what we'll do today is I'm going to give you a bunch of rules, Okay, so a procedure basically that you can follow in order to determine what do I do with a particular assignment statement, how do I derive the post condition from its pre-condition. Okay, so that's what we'll do today. The first thing we have to do is to talk about what is an inverse function. Okay, how many people are familiar with the notation of a function like f of x is x plus 1? Is that okay? Okay. So this is just a shorthand. Okay, function f of x is x plus 1. It's just saying, because x plus 1 can potentially be a really, really long expression. So instead of repeating that really, really long expression every single time, we just say, okay, we apply function f to independent variable x, and this is what it's going to do. Okay, we're just adding 1 to whatever is in the parentheses to the right-hand side of the letter f. All right. The inverse function concept is usually using a superscript -1 to indicate inverse function. But in this class, since I will be using Notepad to write my notes, I'm just going to use the prime symbol to indicate it's an inverse function. Don't tell your calculus teacher that I'm using the prime for that particular purpose, because they will go haywire if they say, but the prime is the derivative. Well, in this class, I'm just going to use it as a shorthand as the inverse function. Okay. So now the inverse function is something that can undo the function itself. So how do I undo adding 1? Subtracting 1, right? Okay, subtracting 1 is going to undo adding 1. So in this case, the inverse function is x minus 1. The purpose of an inverse function is kind of like an undo, okay? So that means if I apply the undo to the do of x, I should get x back. Okay, this is the property of an inverse function. F prime is the inverse function of f, and that is what it's going to do. Okay, is that okay so far? The property of an inverse function. Okay. So I will just give you an example and prove that x minus 1 is the inverse function of x plus 1.
So it's not necessarily mathematically inverse, like 1 over x, because that's...
It is not the reciprocal. It is the inverse of a particular function. It reverses the
like an operation.
It's a reverse operation.
Okay.
Yep, you can look at it as a reverse operation. So let's go ahead and try to prove this one. Okay, f prime in this case applied to f of x is what? Okay, what exactly is f of x?
X plus 1.
X plus 1. Okay, so we put x plus 1 here. Does everybody follow? How I go from here to here? I simply expand. I expanded what is f of x, and by definition, in this case, f of x is just x plus 1. So that's why I get f prime of x plus 1. When I say f prime of something, what am I doing to that something? I'm just subtracting 1 from that something, right? Because according to this, f prime of whatever is just that whatever minus 1. Well, except in this case, that whatever is x plus 1 to begin with. So now I'm dealing with x plus 1 minus 1. And if you remember the associative property of addition, you can now switch the order and group 1 minus 1 first, but 1 minus 1 is just 0. X plus 0 is just x.
Where'd you get the minus 1 from? Is that from the inverse?
From the inverse. Because when you apply f prime to whatever, it is the whatever minus 1. In this case, I applied f prime to x plus 1, so I get whatever x plus 1 is minus 1.
Okay.
What about x?
Hmm?
What about x?
What about?
Where is x minus 1? There's only minus 1.
When you apply f prime to something, you take this entire something and you subtract 1 from it. And that's what this is saying. Is that okay?
Yep.
All right. Is everybody sufficiently convinced that x plus 1 in parentheses minus 1 is the same thing as x plus open paren 1 minus 1 close paren? Yeah. Because that's the associative property of addition. Yep, go ahead.
What if you had something like x squared plus like 2x plus 3? Like, what you're saying is we're trying to get back to like a singular x, and the inverse
Yes.
of that would be kind of the inverse of that.
Can be complicated, but in this class I try to use something that is kind of obvious, like
Okay.
Yep. All right. Now, but sometimes an inverse function may not exist. Okay, so I say sometimes an inverse function does not exist. Okay, I'll give you one example. If I define f of x to 5, then there's no inverse function. Now, if you look at the job of an inverse function, it's really quite simple. Starting with a destination, I want to be able to reverse back to the origin. Okay? A function is a map. And I don't have a pen. Oh, I do. Okay, right here. Okay. A function is essentially what we call a map. Okay? So if you start with a particular value, a function, let's say this is function f here, it takes this value and it brings you to a particular destination. Okay? And if you start with a different value, it can bring you to a different destination, and so on. Okay? That's what a function does. The inverse function is basically saying, if I start with the destination, can I reverse this course all the way back to a single origin? That would be what an inverse function is doing. But the key word here is to back to a single origin. I start with one place, I end up with another place. But if I start with the destination, do I always know how to get back to that one single point of origin? That is the question. Okay? If that is possible, then the inverse function exists. But what if I have f of x equals 5? In other words, the function applied to any type of value just gives you the single answer. So in this case, I can start from a different origin. It ends up here. I can start with another origin. It ends up here as well. I can start with another origin. It still ends up in the same place. So the question now is, starting with my destination, can I reverse back to a single point of origin?
No.
No. So if that is not possible, then we say the inverse function does not exist. There's no way to reverse that operation. Is that okay so far? Okay. Now this is not a math class, so your math professors will be able to explain what is a function and an inverse function in much more glory details. But in this class, we'll just say if I cannot go backwards, then it does not exist. So in this case, f of x equals 5 does not have an inverse. Okay? And generally speaking, if the definition of a function does not involve what we call the independent variable, in this case it is x, if x does not appear on this side, it does not have an inverse function.
So if it's just a number, it's not.
Say again?
If it's just a number.
If it's just a number, or if it is y, it still does not exist, because it maps every single possible value to the value of y. Whatever it is, it doesn't matter, because y is still representing a single value. So that's why it still doesn't work.
So it has to be a variable plus.
It has to be, this side has to involve x in order for that function to have a chance of being reversible. Okay? Because I can also give you a tricky case like this. It is not reversible. Even though x minus x definitely mentions x, it is not reversible. Why is it not reversible?
You don't know what x is.
Because whatever x is, x minus x is always 0. So I'm mapping every single value to a single point of 0. Starting with that single point of 0, there's no way for me to go back to the origin, to a single point of origin.
So it has to be two different ones. What if it was x and minus y?
If it's x minus y, I can still go back. Okay, if it's x minus y, I can just say plus y.
It has to be two different variables, and it can be inverse.
Well, it has to be reversible, okay? Because x minus y is reversible by adding y to the result. Is that making any sense? Yep. Yep.
It's only if you're adding. It's only if you're adding, not multiplying.
Oh, multiplication works too.
Right.
Yeah, because if I have f of x equals to 2x, what is the inverse of this? X divided by 2, exactly. Okay. And I'm not going to give you any really tricky cases like log or the exponent of. Those things are kind of tricky because it's reversible, but not for all possible values. Okay. Even square and square root is a little bit tricky because square is technically irreversible, because there are two square roots. One is a positive and the other one is negative, mapping to exactly the same square. So that's why, technically speaking, it is not reversible either. Okay, but in this class we'll just use simple ones like addition and multiplication, and none of the really tricky ones. All right, so that's the concept of an inverse function. Now this is useful because the way we look at an assignment statement is like this. Okay, so look at an assignment statement like this. Okay, so every assignment statement has a line number. So let's say this is n is representing the line number of this assignment statement, and we'll use LHS to represent the variable on the left-hand side, and I'll use RHS to represent the right-hand side expression. In other words, I'm not using a variable named LHS. LHS is simply a placeholder of a particular variable in an assignment statement. RHS is not by itself an expression. It is a placeholder for an expression on the right-hand side of an assignment operation. Okay, so what we want to do here is to do the following. Okay, so I'm going to spell out the steps here. Step 1, define f of LHS as RHS. Okay, just take whatever the variable is and stick it inside the parentheses, and take whatever the right-hand side of the assignment is and stick it to the other side of the equal symbol. Okay, this is just how I define the function f. Step 2, find an inverse function f prime for our particular function f. Okay. Step 3, 3a. Okay. If an inverse function exists, use the substitution operation, and I'll explain what it is later on. Step 3b, if an inverse function does not exist, use the forget operation. Okay, so I'll explain what a substitution operation is and also what a forget operation is. But as far as these steps are concerned, do we know how to follow these steps? Step 1 is really just to look at an assignment statement and say, okay, I break it up into the left-hand side and the right-hand side, which we do that already. So step 1 is really just saying, okay, what is the function that we're dealing with? Step 2 is a little bit more tricky because we need to find the inverse of that particular function. Step 3a is saying, okay, if you can find an inverse function, great, we can use the substitution operation. Step 3b says, if you cannot find an inverse function, then we can use the forget operation. Okay? All right, so the next thing I have to do is to say step 3a1. Okay, 3a1 is indicating what is the substitution operation. The substitution operation is really useful because it helps you derive the post condition from the precondition of a particular line. So in this case, the post condition of line n is the result of applying the substitution operation on the precondition of line n. What you do is you take all the occurrences of the left-hand side and you replace all of those occurrences with f prime, which is an inverse function, applied to the left-hand side variable. That's it. I mean, that really is the template of how to apply the the substitution operation. And then step 3b1 is to derive the post condition of line n by using the forget operation. The forget operation says go through the entire precondition of line n and remove any component that mentions the variable on the left-hand side. But on top of this, we can also use a conjunction and say, but from here on, the left-hand side equals to the right-hand side, because that's what the assignment operation is going to do. So these are basically templates. Okay, this is a template that you can apply whenever you see an assignment statement. Apply these particular operations so that you can derive the post condition of that line from the precondition of that line. You only use one or the other rule. Are we doing okay so far? As far as the steps are concerned, I'll give you a few examples.
Can you just say like what
like how you, can you just say what it means again? Like as you were putting like.
I'll go through the entire thing. I will actually show you what it does. Okay, I'll give you a solid, concrete example. Okay. Since I'm pouring concrete in my house, I'll give you a concrete example with rebar. Actually, they don't use rebar anymore. They use fiberglass embedded into the concrete mix now. All right. So are we ready for the concrete? Yes. Okay. So I'll give you an example, solid example here. Okay. So let's say this is line 45, and line 45 just says x gets. We'll just use one that is fairly common. Okay, x gets x plus 1. Okay, so if I apply step 1, that means I'm just defining the function f. Okay, so step 1 basically says define f of x as x plus 1, because the left-hand side is just referring to the left-hand side of the assignment statement. The right-hand side is referring to the right-hand side of the statement. And I'm just giving it a symbol of f to indicate this is the function that we're dealing with. Are there any questions about the application of step 1? Okay, so now we can move on to step 2. Step 2 says I want to find an inverse function f prime for our function f. Well, do you think there's one here?
Yes.
We just kind of went through that example a little bit earlier. So we say f prime of x is x minus 1. And if you have really kind of doubt that this is going to work, you can prove to yourself too. You can say f prime of f of x is f prime of x plus 1, which is the whole thing is x plus 1 minus 1, and that goes all the way back to x. So we have just proven that the inverse function is in fact the inverse function.
You don't have to do the proof.
You might want to at least do it to convince yourself that that is the right inverse function. Now, for something obvious like that, obviously you don't have to do it. But for something a little bit more tricky, you might want to go through this derivation to convince yourself that that really is the inverse function. Okay. All right. So that's step 2. Are there any questions about step 2? Now, you can also make a conclusion that there's no inverse function. I'll go through another example where there's no inverse function, and I'll tell you exactly what you have to write in that case. But in this case, an inverse function does exist, which is great.
So we're done. We did step 3.
We are now moving on to step 3a.
Okay.
Yep. And we can move on to step 3a only because an inverse function exists. Okay, an inverse function exists, use the substitution operation. All right, but according to step 3a, 1, then we can just say the post condition. This is really just looking up the line number. So we say the post condition of line 45 is the result of applying the substitution operation on the precondition of the same line. And then what we do is we look for all occurrences of the left-hand side variable. Remind me again, what is the left-hand side variable on line 45?
X.
X. Very good. So we find all occurrences of x, and we place every single one with f prime, which is our inverse function, applied to x itself. Is that part okay? I'm just applying the same stuff that I talked about in the template to this specific case with a specific line number, a specific left-hand side variable, and a specific right-hand side expression. Yep.
So what exactly is, okay, so it's saying substitute pre-45, which is just x, right?
No, pre-45, I have not defined what is pre-45 yet, so I have to give you that information as well.
Okay, but then we're moving on to, then we have a comment and we have x there. What does that mean? I know what the variable is. What is it? I'm trying to figure out what that
yeah, I'll explain that. Just hold on a second. I need to add one more thing here. Okay, since you guys are all writing, I'm going to basically write it over here. Assume in this case, for whatever reason, I'm just making this assumption here. The pre-45 is x is less than y, and y is the same as z plus 20. Okay, that's okay. We can just do it like this. Okay. So now, because in order to perform the next step, you have to know what is pre-45. Okay. Now let me just explain again what is the substitution operation. The first part, which is pre-45, is some kind of an expression. Okay, it's a Boolean expression. X specifies every time we see x in pre-45, change it to f prime applied to x.
Can you say that again?
Okay, it means whenever you see something in pre-45 that mentions x, change that x to f prime applied to x, which is x minus 1 in this case.
So like for pre-45, like the first one, x minus y, that would be x minus 1 is
Less than y.
Is less than y?
That is correct.
Is that what you mean? So just kind of substitute it
Yep.
like you would a mathematical function, you just kind of plug in?
Yep. And in fact, I'll do this step by step. So the first thing I do is to basically expand what is pre-45. So in this case, since I told you ahead of time that x pre-45 is x is less than y and y is z plus 20, I'm just going to expand it here. In other words, I'm just going to take this part and say, oh, okay, I do know what is pre-45. I'm just expanding it, extending pre-45 in place here. Is that part okay? All right. And I will still have to finish the whole thing, so I will still have to specify we find occurrences of x and replace each one with f prime applied to x. But I know what is f prime applied to x because it is over here. So that means whenever I replace x, I replace it with x minus 1. Is that part okay? Is everybody seeing the connection between the line prior to the one that has the blinky cursor and how it leads to the next one? Is that okay? So the final product is really just a replacement. Okay, it's really just a mechanical replacement. In other words, now this is, you may not want to copy this right away. Just watch what I'm doing with it first, and then you can copy the actual end result. Okay, so that basically means if I find x here, excuse me. Thank you. Okay, so that means whenever I find an occurrence of x, I replace it with x minus 1. So here's an x here, so I go ahead and replace it with x minus 1. I always put parentheses around the inverse function, just so that we don't have to mess around with operator priorities. In case it's right next to a multiplication, we don't have to worry about that sort of thing. And that's it. I'm done. The reason why this works is because the effect of line 45 is to increment the value of x by 1. So I find an inverse function to reverse that effect. If I apply the inverse function to the value of x after the assignment statement, I essentially get back to the value of x prior to the assignment statement. And that's why I can maintain the same relationship of how x relates to everybody else, except it's just x minus 1, because x minus 1 in post 45 is the same value of x before line 45. Go ahead.
Okay, so I think you kind of answered my question though. So basically the point of doing this is to basically get your values back to what it was before you executed line 45?
Yep. Yep. And that's why it is nice, because I get to keep basically the entire precondition, except every time I see x, I have to reverse it to the value that it had before statement 45 in this case. Okay? So that's the rationale of why this works. Now, you don't have to go through the algebraic manipulation here. If you want to say x is less than y plus 1, fine, okay, not a problem, but you don't have to do that. Okay, just leaving it like this one is fine. Okay? All right. So that's one particular case. So now we look at the other case. Okay, what if I cannot find an inverse function? So we'll just go ahead and imagine here is line 24, and on line 24 x is initialized to a value of 20. Okay, and this time I'll give you the precondition of line 24. So I'm just going to give you the precondition in this case and say that the precondition of line 24 is x is greater than y, and y equals to z plus w. Okay, so that's a precondition. So what we want to do is go through all the steps again. Step 1, define f of x is 20. Because this time the right hand side is just the constant 20. We'll just go ahead and define it as such. Step 2, we say the f does not have an inverse. F does not have an inverse in this case, and it's pretty obvious because the right hand side does not mention the variable on the left hand side at all. Okay, that's pretty much a conclusive type of thing. It's like, okay, cannot have an inverse. So because it doesn't have an inverse, we have to use step 3b, excuse me. In 3b, we say use the forget operation. In 3b1, we expand it out and say post line 24. In this case, the post condition of line 24 has to do with forgetting something in the precondition of line 24. Everything that we knew about x, we better not use it anymore because we just changed the value of x. But on top of that, now we know x is 20 because that really is the effect of line 24, is changing it from whatever you had before to 20. Are we doing okay so far with this? Okay. So now we go ahead and expand what is pre-25. Pre-25 was given to me like this. So for me it's easy, I just copy and paste. For you guys, you have to kind of really write it down. Or you can just leave it to the recording and watch it later. Okay? Is this part okay? Is everybody following why I went from this line to this line here? I just expanded pre-24. Is that okay?
Basically, you just plugged in.
I just plugged it in, exactly. I just plugged it in. Okay, so now I have to actually perform the forget operation. In other words, I look at this part here and I say, is there any comparison here that makes use of the variable x? Well, unfortunately I do, right? The first part, x is greater than y. Well, I didn't say what x was, and I just said it was greater than y. I didn't tell you what was z or w, so there's no way I can guarantee x is greater than y is still true now that I change x. Is that making any sense? So that's why the forget operation is just doing exactly that. Okay, forget about x. We can only claim that y is still z plus w because the assignment operation does not change w, z, or y. So that's why this equality is still true. But we know one little thing extra now, because x equals to 20 has to be true at this point. Is everybody convinced that x equals 20 has to be true as a post condition of line 24? Yeah. Because that's what line 24 is going to do, is just changing it to a value of 20. Yep.
If it was y equals x plus w, then I would forget that too, or would I just say minus 20?
Say again?
If it was y equals x plus w for the precondition, would I forget that too?
Yeah,
or
you
would
will
I
have to
just
forget that.
subtract the 20?
No, you will have to forget it because you did not know
What x was before.
exactly. Yep. Yep. The whole point is whatever in the precondition that can be invalidated because we changed the value of a variable, you have to take out all those components because it may not be true anymore. Okay.
It's actually easier this way.
Well, that's but I do want to go through the more intuitive way first, because I think I'm starting to know how different people learn. This is how I would learn it too. Is I would learn the rules of the template first and then apply it to actual examples. But some people would like to use actual examples first and then they generalize into the rules. So it depends on your learning style. Okay, so now we still have one question because now we can deal with programs with a single line. So how do we deal with programs with multiple lines, right? Okay, so I'm just going to give you a quick example here. Line 31 is it gets x plus 1. Line 32 is y gets the value of x, and so on. Okay. I'm not even going to go through the pre and post condition thing, or using the substitution rule and the forget rule here. What I want to do is to say, okay, you will be able to derive what is post 31, but how do you link post 31 to line 32? How does line 31 relate to line 32 in this case?
X equals Y.
The precondition of line 32 is the same as the post condition of line 31 because these two lines are sequential.
Now is that step one? Or is that before that?
Say again?
Is that step one? Or is that
No, that's this. You do this after you derive post 31. Yep. Go ahead.
So, okay, so like for instance in our homework, if it was 1, 2, 3, or 4, would we could either write pre or post because it's the same thing. Essentially, like, so I could either write pre.
No, you have to
or
start
post.
with pre. Yeah, you always start with the precondition. So when you go back to the homework assignment, the precondition is given to you already. It is just true.
Right, but I'm saying if I was between 2 and 3, so it could. Do I have to do pre 3 and post 3, or do I have to just do post 2 and
You
post
have to
3?
do it line by line. So that means in this particular case, you have to start with.
Right, I get that.
Yeah, so between line 2 and 3, you will have to derive post 2 first,
Right.
and then you use it to and say that pre 3 is the same as post 2, and now you have a pre 3, and then you can use whatever rule is applicable to derive post 3.
Okay, so I just copy it.
Exactly.
Okay.
Yep. Or you can just state, post 3 equals pre 2
Oh.
without actually stating what pre 2 is. I mean, what post 2 is, because post 2 should be stated somewhere before that already.
Okay.
So you don't have to duplicate all that. But since you'll be using an editor, you can copy and paste it too, so that won't take you a lot of time. Okay. So are there any questions? I think you guys have everything that you need to work on this homework assignment now. And it is due in 1 week. So I would suggest you guys to start on this as early as possible, so that next time on Tuesday, if you have any questions, we can talk about that. Okay. Are we doing okay?
Are you using the asterisk as a multiplication?
Yes, the asterisk means multiplication. Good question. For each one, so you will have step 1, 2, 3, step 1, 2, 3, step 1, 2, 3 for each of them.
I had a question.
Right.